Like I said in class, we're only going to do the first half of these notes, so I just want to be sure everybody is aware of that. You don't have to fill out these entire notes tonight. We're going to get the other half tomorrow. But today's section is just going to set us up for understanding how heat transfers from one place to another, and there are a few rules about how that usually works. I just want to be sure we all remember that heat is the movement of thermal energy from a substance at a higher temperature to a substance at a lower temperature. Remember, thermal energy deals with the movement of molecules, and so the higher temperature means that the molecules are moving a lot faster and they're more spread apart. So what they want to do is try to get away from each other, and when they have the opportunity, they're going to take it by moving to a place that has a lower temperature. So rule number 1 says that heat always flows from a warmer place to a cooler place. And this picture at the bottom kind of demonstrates that. So the source of the heat, the source of the energy is going to try to spread out. It's going to move towards the areas that have less energy. It's kind of like a domino effect. So there's no such thing as cold transfer or coldness. There's just heat loss because heat travels in one direction. So like when you put your hand on a cold door, like during the winter time, it feels cold because the heat is transferring from your hand onto the door itself. And so it feels cold to you, but the cold isn't necessarily transferring to your hand. The heat is leaving your hand, which leaves a feeling of coldness. When heat flows into an object, the object itself expands. So the molecules spread apart, and that's because the energy has increased. And when heat flows out of an object, the object itself contracts. So contracts means that all the molecules move closer together and they stop moving around as much. The third rule we have here is that hot liquids and gases always rise and cold liquids and gases always sink. So that's one reason if you ever are driving in the car and somebody turns on the heat, a lot of times it's better to turn the heat on blowing on the feet instead of the face, because that way when the heat's blowing on the feet, it will eventually rise up to the top and fill up the whole car. It's also the reason that when we boil water, we have the heat source at the bottom of the pot, and the water molecules will heat up and eventually turn into a vapor. And when that happens, the vapor, the gas molecules are further apart than the water molecules are, and so that means that it's less dense. It would rise to the top, and then the cold water is pushed down to the bottom, and that's why we have this like cycle that goes on, just like in this picture here. Finally, we've talked about this already with our phase changes graph, but I just want to make sure that we understand that temperature does not always change when we add or take away heat. The reason is we have phase changes. And just to reiterate what we've talked about and what we had our quiz on today, there's no change in temperature during a phase change because all of that heat energy is being used to break the bonds between the molecules. That means that it's being used to move the molecules either away from each other or closer to each other. And because it's all being focused on the spacing, the temperature itself or the speed of the particles themselves does not change at all. So, like I said, this is a really quick video. I just wanted to set up what we're going to be talking about in class tomorrow, and then we'll finish up these notes tomorrow night, talking about specific ways that heat transfers.